Hello, all. Let's start with our today's DSA journey with this amazing visualizer by ChaiCode, which is dsa.chaicode.com. Use this link to get a 7-day free trial. Let's start with our today's DSA, and today we will do the permutation in string in sliding window. So fixed size window plus frequency matches. Okay. Given two string s1 and s2, return true if s2 contain the permutation of s1 as a contiguous substring, a window of side length s1 whose character count matches s1. Okay. So this problem tells us we that we are given two string s1 and s2, s1 and s2. We are given two string, and we have to find that if s2 contained some permutation of s1. Okay, so what is a permutation? Let's suppose ab. So the permutation of ab will become ab and ba. Two permutation of ab, and if you go abc, the permutations will become A B C B C A C A B C B A. So every possible way we can make a permutation also. Like everything. I think there should be more permutation. Let's just remove it. A C and B A C and B C A. So there are total 6 permutation for this string 3 and 2 permutation for this string of size 2. We have to find if this S2 contain any permutation of S1. Thus is AB here. So AB or BA. Any of these A are actually in this string or not. So here BA is the one. So now we can clearly see that S2 contain the value of S1. Okay, we have to find out this AB or BA into S2. So take this example. So how could we solve it? Okay, so most solutions actually we can use a map. Seriously, we can use two maps, one for this string, another for this string. Okay, so first we take a map for the S1. So just store in the S1 the character and the character count of the S1. Okay, so we are storing character and the character count. A appears one time, B appears one time. This is for S1. Now for the S2, for S2. Okay, but here eh, this is for S2. Similarly, character then count. So first, what is the size of the S1? 2. Take first 2, E1, I1. Take of the character of the first S1, which is our K, we can consider K. And after reaching this, just check, does this character count E1, I1 is matching with this character count of S1? No, we don't match it. For this reason, what we do, we just increase our array. Okay, we just increase our array as similar as that. So this is our string. So this is our string, and we just at the first we are taking 2. because the size of S1 is 2. So take the first two character and store in the map. There we store it and check if this both map are equal or not. This both map are not equal. This both map are not equal. Then just go to the next point, which is D here. But before that, first remove this E. Now add this D here. Okay, so just a minute. So now this map, which is the map of S2, which is the map of S2, is it match with the S1? No. For that reason, just 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 increase this pointer. Just increase this pointer to B. Okay, and remove the last point, which is I. So remove this I and add this B here. So B became 1. Does it this map S2 is matches with S1? No, no, not matches. So now remove the D also. Remove the D, which is our previous element, and now add the next element, which is nothing but the A. So add A here, A1. So now check the map. A and B both are present in the map. In both map, yes. The frequency of these maps are same. Yes, both are same. So it means yes, there is a permutation of string S1 which actually have a substring of S2. Okay, so we got the S1 permutation of S1 into S2. We got the permutation of S1 into S2. Okay, so in this way, using this map, two maps, we can easily check the permutation. Okay, now let's visualize it. Does the H2 contain the permutation of S1 as a contiguous substring? Okay, as a contiguous substring, we don't need something like a subset where everything is different. We need a substring. A permutation of the window of length S2 equal to 2 whose letter count equal to S1. So first build the S1, which is A1 B1. We got our target A1 B1. We got our target here, which is A1 B1. Now first K element, which what is K here? K is the size of S1. K is the size of S1. Okay, so we got the K here and add the K element, add the K element to into the which is nothing but another map, which is nothing but another hash map to store value into value into count of that value, character into count of that character, character in character and count, like this character and the count. Similarly, both of case two maps we store. Does it match with this is EI? Okay, so it doesn't match with anything, so we just increase our window, increase our window. We just increase our window. We left the E and add the D. Simple sliding window approach. We remove the left one and we add the right one. We remove the left one, we add the right one. And here we are using a fixed window, and the size of the window is the size of the string S1. Okay, now add the D and also check. Now currently our target is 1, but the window is A0 B0. We have I1 and D1. Okay, we don't need that. Okay, we don't need that. So for that reason, increase the I. Okay, target B1 clearly mentioned A1 B1, A0 B0. Our target is A1 B1, but our window size is A0 B0. Okay, it doesn't match. Go to the next. Okay, it matches. Actually, see here matches A1 B1, A1 B1. It matches. It matches. It match. Okay, we got our answer. So this is our solution. Let's write down the pseudocode here, which is nothing but we are taking a function which contains two string s1 and s2, and first take the k, which is nothing but the length of s1, a T is a character count of S1, which is a map, which is nothing but character count of S1, every character of the string S1. Now build the first window. Build the first window. Build the first window using all the letter of S2 from 0 to k minus 1. Okay. Take the first k element of the string S2 and build a window. Build a window. Then, they have to, on that window from 0 to k minus 1, we have to count each into window. Character into window. We have to count each character of the window S2. Okay. So now we have to check that if the window, the window, if the window is equal to t. T is our target, which is nothing but the character count. If it matches, then simply return true. If it's match, then simply return true. Otherwise, now perform the sliding window. Okay, every time perform the sliding window from starting to k till the end, which is nothing but s2, length of s2 minus 1. Okay, so first s2 remove the element from s2, which is r minus k, which is r minus k. So remove the last element of the leftmost element and then simply add the rightmost element, s of r. Add the rightmost element. And every time we have to check if it's matched with the window or not. Match with the window or not. If not match, then simply return false. If matches, return true. If not matches, return false. Let's evaluate it first. Yes, we nailed it. Let's go to the question. So this is our pseudocode. Okay, so this is our pseudocode. This is our pseudocode which you have to perform here. Okay, there is something error in lead code. Let me pause the video and check when the lead code is okay. Yeah, so now the lead code is properly opening, and now this is our pseudocode. We have to now build a proper code for this. Okay, for that first we have to calculate as usual the size of the array, both of the arrays. Let's take the s1 as k because we are taking here k size window. So let's stick with our pseudocode, which is s1 dot size, and take in here, that is s2 dot size. Okay, and just put a condition here: if any cases k is become less than n, so just return false. Okay, so it's meaning that the s1, okay, the s1 is large and the s2 is small. So it means like this: the s1 will become abg. Suppose this is our s1 and this is our s2. Okay, for this case we have to find if any permutation of s1 found in s2 or not. It is not possible because if the highest chance could be both of the size of both of s1 and s2 are equal. If not size are not equal, then the s2 should always become greater than s1. The size of s2, the size of s2 should always become greater than the size of s1, just to fulfill the condition. Okay, So if any cases s1 size of s1 is bigger, then we just simply return false. Okay, now just take two maps. Here we are taking up two vectors. How? Let's check it. This vector is nothing but target, which is 26 letters starting from 0. And another vector we are taking, that is window, which is also 26 letters starting from initialized from 0. Why we are taking a vector? The reason is simple. Uh, at most there are only like string, so everything is a character, so we have only 26 character. Okay, so easily we can take this. Clearly mention s1 and s2 consist of lowercase English letters, so English letters are 26 English letter, so easily we can fit into an array. Okay, so into the array, simple like that, we are taking an array of 26 letter, where 0 1 2 goes 25, so total are 26. So 0 represent a, already it's lowercase a, 1 represent b, 2 represent c, similarly 25 represents z. Okay, so and we can easily store our count here into the value, because we are taking an integer here. So easily with this 26, with this array of 26 or vector of 26 size, we can easily do the work of a map. And also checking this is very simple. Checking the value, like we are checking every time here, like the window is equal to target here. So we can easily check the maps, or we can easily check the vectors or the arrays here. Okay, so now our first work is store all the character in target, all the character of s1 in target. Okay, then character, then simply store the first k character of s2 into the window, into the window. Then simply check for sliding window, like check for, not sliding window, check for, check if it is valid or not, as simple as that. So first we have to store all the value of s1, all the value of s1 into the target. Okay, so for that, every character in s1, so just store. So target of, how could you store? The character minus a. So everything is lowercase English letter, so we are taking this a here. So this character minus a would actually return the values here. So if the character is a, so a minus a will return 0. If the character is b, so b minus a will always return 1. Why? Everything stored in the ASCII table format. So okay, let's go here. So everything stored in our computer in a ASCII format. So if we go here and check the ASCII table, we can found a as 97. This is the decimal value, I guess. Yes, this is the decimal value. So a as decimal, octadecimal, binary. Okay, so the small a as 97, b as 98. So every time computer occurs character ch as b, it will convert it into a 97. Then we are removing it with a, it's converted with 90. sorry, the B would converted the B, the computer, the converted the B as 98, and it will converted the A as 97, and it is give us 1. Okay, so similarly we can easily say like let's take as G is 103. So G is 103. So G minus A. So G minus A would become 03 minus 97. So 336. So 6 are here. So in the position 6 we store the value of all G here. Okay, also the value of G like A, B, C, D, F, G. Okay, so if we take A as 0, 0, 1, 2, 3, 5, 6. Let's see, if we started from 0 with the alphabet, the G always stay at 6, and also in this calculation we found G as 6. So we can easily store our value correct format using this simple trick. Okay, so we just increase the value at this point because with this ch minus a we just found the index, and at the starting the value are 0, so we found the index, we go there and get the value 0 here and we increase the value. Okay, as simple as that. So now uh, we are taking first k character from s2. So for that, for int starting from 0, I less than character I plus plus. So we stored it in Windows. So window s2 of I. For the second character s2 of I, for every index we got a character, then we get the index of the character and just increase the character. Okay, so we got the index and we increase it. With this we got our first k here. So now check if target is equal to window, then simply return true here. Okay, so if the target is equal to window, we simply return true. Okay, because we are checking that if every value in vectors are equal or not. Using this, we are using vector, so we can easily use equal to check if all values are present or not. Okay, now simply if not present, then simply we go to our next step where we just perform our loop, which is nothing but r, which is nothing but starting from k of s2 till the end, taking every value here, and then just simply add at the first. Let's do it here. The left character, then add the right character, remove the left character and add the right character, and then simply check if it match or not, so first remove the left character, which is nothing but s2 of r minus n, s2 of r minus k, s2 of r minus k, because actually we are using k window at the first. Okay, minus a, we got our the index and we remove it. Similarly, we took the left index or the next index, so s2 of r minus plus plus, check if it's match or not. So if target is equal to window, then simply in any time we encounter a permutation, it means we anytime we encounter a permutation, so we just return true, and at the end if nothing works just return false. So every time we remove the left one, we add the right one and we check if it's match or not, as simple as that. So okay, it give us a wrong answer. So why we are getting this answer as wrong? Okay, target of is windows of s of I minus a plus plus from the start to the kth value. From the kth value, remove the left character, which is nothing but the r minus k. So k minus k would become 0. Okay. Then simply remove the character from at the next character, which is at k. Yeah. And if window equal to target equal to window, just return true or return false. Am I missing something? Then take every character at the target. Okay, let's run it again. It should work. It gives us a false. Why? It should give us a true. So actually every time it returns a false. Yes, let me check and return. And making this mistake every time the k should be greater. The k should s1 is greater. We check the condition here. We check the condition here. Check here also. If the k is greater, then it should return false. Yes, it's working. And what is the time complexity? Is the length of s1 plus s2. Why? Because we are storing the length of s1 here, and we actually use this loop to traverse the whole s2. So the time complexity, will become big O of, okay, let's big s1, length of s1 plus length of s2, because at the first we are storing the value into this target map, then we are storing everything into this windows map. Okay, and what is our space complexity? We are actually using a target of size 26 so at max our space complexity will become big O of 26. And also every time in any storing only the size of the s1. Why? Go here. We are taking the size, storing the size of the s1 size. We are storing the size of s1 into the target for checking. And every time the window size is also fixed to be k, size of s1. So we can easily say the space complexity will also become size of s1. This is our time and space complexity. Time complexity of big of s1 and s2. Space complexity is big of 1. Why? Because they are taking big of 26 and 26 is a number, so at max it's become 26. It never become, and it is a mistake, not s1. Why? Because if that's a mistake, extremely sorry. So it always become big of 26, because if there are anything the size is beyond 26, if the size become beyond 26, it only store the 26 value because we are storing the count, and we can easily consider as big of 1 because it is an integer. Okay? So for that reason we are having time complexity as big of s1 s2 and space complexity is big of 1. Okay, we are storing every value of s1, but if s1 has duplicate value we can easily store it into this 26 array because it is our 26 array which consider all English alphabet character. So the time complexity will become big of s1, length of s1 plus length of s2, and then space complexity will become big of 1. Okay, this is our question permutation in string. Okay, go use this visualizer link to get a 7-day free trial. Go use this link, a 7-day free trial. Use this visualizer at dsa.chaicode.com. Thank you very much.